Hello everyone, welcome to CS with RS. In today's session, we are going to brush up the fundamentals of a topic that we all have studied, which is angles and trigonometry. And one point to clear, this session is about revision. We are not going to dig deep into every topic and subtopic. And by the end of this video, you will develop an understanding of how angles transform into directions and why direction actually matters in machine learning. Now, you may have a question here like, how does trigonometry actually matters in machine learning? Like, why should we study trigonometry for machine learning? Let's better understand with an example. Let's say I have these axes. This is my x-axis, this is my y-axis, and I'm drawing a circle here. Okay, this is a circle. Okay, now when I say angles, okay, angles value like 0 degree, 30 degree, 90 degree, 180 degree, or maybe 360 degree. So as humans we understand, like for example 0 degree is, if we start from this point, this is parallel to x-axis. 30 degree will be something like this is 30 degree. 90 degree is this perpendicular. When I say 180 degree, it basically means this is 180. 360, it means one complete rotation. So if we start from this point, from 360 we reach back to that point. So as humans we understand that, but from a perspective of an ML model, angles are just a number. If I say angle, for a model it is just a number. Let's take example of 0 degree and 360 degree. For 0 and 360, they are huge difference. A model will say that these two numbers are very different. Why? Because there is a huge difference. The difference between both these numbers is 360. But as humans, we know that 0 degree and 360 degree, and not just as humans, geometrically speaking, 0 degree and 360 degree, they point in the same direction. We completed one round of the circle and we reached back to same point where we started. If we started from this point, we reached back here. So this point represents 0 degree and it also represents 360 degree. So to have ML model develop this intelligence, this is where trigonometry comes into the picture. We represent a point using trigonometry identities like cos theta and sin theta. This is how we represent a point. For our example, if we take the values of cos and sine for 0 degree and 360 degree and we calculate both these points, let's say if we calculate point for 0 degree, we can say cos 0 is 1, sine 0 is 0. Similarly, for point at 360 degree, we know that cos 360 degree is 1 and sine 360 degree is 0. So both these points are 1 comma 0 at 0 degree and 360 degree. So representing points in terms of cos and sine, these trigonometrical identities, actually helps an ML model to better interpret angles in terms of directions, because in terms of direction, if we see, this representation actually helps us to determine the distance between both these points, and here the distance is 0 because these two points are at the same place, and this distance basically is the angular closeness. Before we move ahead, let's take a look at the roadmap for this session. This session is basically divided into 9 parts. First we'll start with angle, then we'll move to radian and then check out the difference between degrees and radians. Then we'll see why ML prefer radians over degrees. We'll look into sine, cos, tan, like what they represent, what they mean. We'll also check out the sine system and the quadrants. We'll have a look at angles, slope, gradients. We'll check out some common angle values, and then we will discuss the use cases of trigonometry in real world machine learning. Let's start with point number one. What exactly is an angle? Let's say we have this ray here, OA. Now if I rotate this ray in anti-clockwise direction, like this, and I call it, let's say, A dash. So this figure that we have obtained by basically rotating this ray that we had is basically called this A dash OA. This basically is an angle. This is how we represent. This is an angle. We can call it anything. Let's say we call it theta. So this angle AOA is equal to theta. That's how we represent an angle. Now here O is basically called the vertex. If we are too familiar with this, OA is basically called the initial site, because it was the initial place from where we moved our ray OA. This OA dash is basically called the terminal side. Next we have measure of an angle. So this amount of rotation that we have here, which we have represented by theta, this amount of rotation is basically the measure of an angle. There is another concept here, sense of an angle. Sense of an angle, it means if the angle rotates in anti-clockwise direction, let's say in this direction, if this is the angle, if this is the rotation, then this becomes a positive side. But if the rotation is clockwise, then this is the negative. This is positive sense, this is negative sense. Next we have quadrants. When two lines intersect each others at right angle, we call it XO, X dash. This is YO and Y dash. So it basically divides this entire region into four quadrants. This is first quadrant, this is second, this is third, and this is fourth quadrant. So these are basically quadrants. And these two lines, XO, X dash, YO, Y dash, these are basically known as the coordinate axis. Next is radians. Now there are two ways to measure an angle. One is degrees, another one is radians. Now degrees we are all familiar with, and humans find degrees more comfortable, while machines prefer radians. So what exactly is a radian? Radian basically measures the amount of distance covered by an arc on the circle. Now that basically is a radian. Let's better understand with an example. Now we have a circle here. This is our circle. This is the center of circle, and the radius of the circle is r. We have drawn this circle with radius r, and let's say we have an arc here, AB. AB is basically an arc on the circle. Now let's say we draw this AB is basically equal to the radius of the circle. We have an arc which is same as the radius of the circle. So A radian is basically arc length divided by radius. Now that's how we measure a radian on a circle. So when we draw an arc of radius r and we divide it by r, so it is 1 radian. Theta is 1 radian. So when we have an arc on a circle which is equal to the radius of a circle, we say that the distance covered by that arc or the distance measured by that arc on the circle is 1 radian. Now when this arc completes the entire circle, let's say this arc complete the entire circle, so distance covered for full circle arc, the distance covered will be the circumference of the circle. And we all know circumference of the circle is 2 pi r. So the radians will be the distance or the arc length, which is 2 pi r divided by radius. R will get cancelled, so it is 2 pi. So we can say that the radian of full circle is basically 2 pi. And in terms of degrees, when we have a complete circle rotation, when we have this complete rotation, we call it 360 degree. So that full circle is in degrees, it is 360 degree, while in radians it's basically 2 pi radians. Now that we know what a radian is, so next is what's the difference between a degree and a radian. Degree basically divides a circle into multiple slices and it measures the number of slices that makes up that angle. For example, let's say I have a circle here. I've drawn this circle. When I say this is the center of the circle. Now when I draw an angle, this angle, this 45-degree angle is basically one slice of the circle. This becomes one slice of the circle. Similarly, when I say 160-degree angle, so this complete becomes another slice of the angle. When I say, or slice of the circle, sorry. When I say 180 degree, this complete, so this half circle basically becomes 180 degree. When I say 360 degree, I start from here. This complete circle, it becomes 360 degree. Now what's the relation between degrees and radians? Okay, we just saw here pi is for a complete circle rotation, which is 360 degree. In degrees it is 360 degree full circle. In degrees we say it's 360 degree, and in radians we just calculated it was 2 pi radians. When we divide both sides by 2, we get 180 degree is equal to pi radians. Now this is a very important relationship that we need to keep in mind. The relation between degrees and now let's try to understand why machine learning prefers radians over degrees. Now there is nothing wrong in degrees by themselves. It's just that ML is concerned with how fast a thing is changing. Like if I say thing is at point A, it goes to point B. So ML is more concerned with this speed of change, this rate of change. And degrees by themselves, they don't measure change. In ML, we are more concerned with gradients, slopes, or how fast things change, the rate of change. And this is the world of calculus and not geometry. So what exactly does calculus needs from angles? Calculus basically asks questions like how fast is sin x changing, and if I have a curve here, so at this point what is the slope, and if I make some changes, whether it's small or big, how does this change affect the output? So these are some questions that calculus is more concerned with. And for this work to work cleanly, angles must be measured in a way that connects angles directly to distance. And this is where we learn radians come into the picture. Why? Because a radian is all about the, in circle we saw it's about the distance of the arc, the distance covered by the arc on the circle. So radians are naturally suited for this, and angles should be able to scale them naturally. Again, radian is preferred over degrees, and they do not introduce extra constants. Like if the angle is in degree, for example, we saw that pi radians is equal to 1 degree. Now if the angle is in degrees, we have to, for 1 degree here will be equal to pi by 180 radians. So if we have anything like 30 degree and we need to convert it into radians, we need to multiply it by pi by 180. So it basically introduces an extra constant for calculations. Let's take an example from derivatives to better understand this point from a derivatives point of view. For example, we know that d by dx of sine of x is cos x. Now if the angle x is in radians here, now one thing I know, we have not covered this differential equations as of now. We will be covering it in next few sessions. Okay, so for now let's just understand that differentiation of sine x is cos x. Now if x is in radian, then it's okay, but if x was in degrees, then d by dx of sine x would have been cos x into pi by 180. This will be extra constant that we now have to add into our calculations. So yes, we can achieve the desired output, but again, when we have x in radians, it's basically a clear approach, and here extra calculations comes into the picture, so it's not that a clear approach. Now one very important thing for us to remember is degrees are used, or better suitable, for measuring angles. That's where its degrees are useful in geometry. But when we have to measure change, how fast or the rate of change of anything, radians are more suitable for that purpose, and ml is more inclined towards measuring this rate of change. That's the reason why radians are more preferred in machine learning. Now let us try to understand the trigonometric functions sine, cos and tan. Okay, first of all, let's not get scared by all these mathematical calculations on the screen. Let's try to understand. Let's say I have this circle, I have drawn this circle here. We have coordinate axis of xox and yoy. The circle is of radius 1. So A is the point A on horizontal axis is denoted by 1, 0. Y is 0, 1, and on the minus side it's minus 1, 0, and y dash is 0, minus 1. Now I have taken a point P on the circle here, the coordinates of which are A and B. A is the horizontal coordinate of P and B is the vertical coordinate of P. I have here an angle of x radian, okay, and we know that radian is basically the arc length upon the radius. So radius here is 1 and it is x, so we can say the arc length is basically x. So this arc length here is equal to x. Now if I have to denote this point AB in terms of trigonometric functions, so the cosine and the sine functions of radian measure, let's say x we know here is taken in radian. So in terms of x which is in radian, the trigonometric functions cosine and sine can be represented as cos of x is a and sine of x is basically b. So this point AB can be represented in terms of trigonometric functions as p of cos of x and sine of x. So this becomes cos of x and sine of x, this point P. Now if we try to calculate the trigonometric ratio of this angle, let's say from point P, if I draw a line here, vertical line that meets this x-axis at point M, so it becomes a right angle triangle. This is a right angle triangle. Now if we try to take a ratio of angle MOP in a right angle triangle, we say OMP, this is a right angled triangle, okay, it's of 90 degree. If we try to take a trigonometric ratio for this angle MOP, okay, now cos, we know that cos in a right angle triangle, cos is basically base upon hypotenuse. So cos of angle MOP will be base is OM, hypotenuse is OP. So cos of angle MOP is base upon hypotenuse and OM is basically A. Point P is represented by AB. Once we draw this perpendicular line, so this distance OM becomes A and PM becomes B. So cos of MOP is OM upon OP, which is A upon 1. So it becomes A. Similarly, when we take sine of angle MOP, sine we know is perpendicular divided by hypotenuse, which is PM is perpendicular here. OP again is the hypotenuse, which is 1. PM is equal to B. This PM is B. So sine of angle MOP is B. Now we know that angle, when we say MOP, which is x radian, but angle AOP is also x radian. So angle MOP is equal to angle AOP. So once we substitute MOP with AOP, we get cos of AOP is A and sine of AOP is basically B. And here from trigonometric functions, we know that cos of x is basically A and sine of x is equal to B. So once we substitute here, we get cos of angle AOP is basically equal to cos of x and sine of angle AOP is basically equal to sine of x. So what we can conclude from here is, for an angle x which is in radian, we can say that the trigonometric ratio for that angle which is MOP here is equal to its corresponding, its value of, in terms of corresponding its trigonometric functions for any real value of x, which could be 10, 20, 30, 90, 180 or whatever. And coming to the representation of these trigonometric functions cos, sine and tan, cos basically represents the horizontal component. We saw here in the right angle triangle OMP, cos is basically OM divided by OP, which is base. Cos is concerned with base. Similarly, sine was PM divided by OP. PM is perpendicular, this vertical component in a right angle triangle. So cos is concerned with horizontal component, sine is concerned with vertical component, and tan is a ratio of these both, vertical and horizontal. So tan is equal to sine theta divided by cos theta. I know that we have gone a bit deeper into trying to understand the basics behind these trigonometric ratio and trigonometric functions, but I just hope the concept must be clear to you guys. Now let's move on to the next topic. Next, let's try to understand the signs and quadrants of these trigonometric functions. Continuing from our previous example, let's say we have drawn a circle here. Okay, we have a point here P, A, B on this circle. and xox represents the vertical horizontal coordinate, and yoy represents the vertical coordinate. Here we have the circle intersects x at point 1 0, b, this is b, let's call it a, this is c, and this is d. So b is 0 1, intersection at c is minus 1 comma 0 because x is minus here, and similarly y is minus here. So at d, the intersection point of the circle d becomes 0 comma minus 1. Now we can see that the value of a in this entire circle, when this point moves in this entire circle, the value of a is greater than equal to minus 1 but less than equal to 1. Similarly, the value of b is greater than equal to minus 1 but it is less than equal to 1. And similarly, for trigonometric functions, we can say that the values of cos x and sin x both are between minus 1 to 1. Now quadrant, as we have seen, when this coordinate of these horizontal and these vertical lines, when they intersect at a point here O, so it divides this entire region into 4 parts. This is basically, this part is first quadrant, this part is second quadrant, this is first, this is second, this region becomes third quadrant, and this region becomes the fourth quadrant. Now in first quadrant, the values of a and b both are greater than 0. So both sin x, cos x, and along with that tan x as well, it is positive here in this first quadrant. When we move to second quadrant, we know a is less than 0, a is negative, but b is greater than 0 here. So sin is positive in this region, whereas cos and tan both are negative. When we come to quadrant number 3, here a is less than 0, b is less than 0, both are negative in this region. So tan is positive, whereas sin and cos both are negative in this region. And in quadrant number 4, a is greater than 0 and b is less than 0 here. So in this case, cos x is positive, whereas sin and tan both of them are negative. So this information is something that we don't have to memorize it, we don't have to remember it. It is just for information. It might come handy in near future. So don't try to memorize it, it's just for information. Let's move on to the next point. Let's try to understand what a slope and a gradient is and how are they related to the angle. Let's take this example here, first one. First we'll deal with slopes, then in second example we'll understand what gradient is. So let's say we have xy axis here, and from point O we draw a straight line. This basically represents the movement from point O to point B. This movement, we were at point O, now we have come to point P. Now when we draw a perpendicular line here on x-axis, PM, we can say that this POM, angle POM, makes an angle of theta here. So slope basically represents the rate of change. How much change has happened when we move from point O to point P. Now when we move, there are changes will happen in two places. Galat. Now when we move on an inclined path, as we move ahead, the distance that we have traveled changes both at horizontal level as well as vertical level. Why? Because this is an inclined path. If we were to move only on the horizontal direction, then only the horizontal path will have change. Similarly, if we were to move only in the vertical direction, in this direction, only the vertical change will take place. But in case of slope, as we are moving ahead, we are covering the horizontal distance as well as the vertical distance. Okay, let's say we are climbing a mountain. It's a straight road on a mountain or on a height. So as we move ahead, we will cover the distance on the road as well as our height will also increase. Okay, so here slope basically is the rate of change in how vertical we have reached, our vertical distance, the height, and divided by the rate of change or that we have on the horizontal axis. So in case of an example, let's say when we say I have covered a distance of 1 kilometer, how much is my height increasing? I say my height has also increased by 1 kilometer. So this x represents horizontal change, y represents vertical change. This is horizontal change, this is vertical change. So this basically is a slope. Now from our previous example of trigonometric functions, we know that in a right angle triangle, tan theta is basically denoted by vertical divided by base, which is PM and OM. But in this example, when we move in an inclined direction from O to P, we know that PM basically represents the vertical change, which is del y, whereas OM represents the change on the horizontal axis, which is del of x. So we can say slope is basically represented by change in y divided by change in x, and that slope is also represented by tan theta. So slope is also represented in trigonometric function of tan, which is tan theta. Theta is this angle here. Now here in this example, our path was straight. This was a straight line. Okay, but what about when the path is curved? This is a straight line, but this is a curve here. So this is where the concept of gradient comes into the picture. So gradient is basically when we have a curved path like this, P to Q is basically a curved path. So in this path at any point, let's say we take a point here M, so the slope at this point basically represents the gradient. So let's say this is a tangent that we have drawn. Okay, so please forgive me for my drawing, consider it as a straight line. Okay, so this straight line is basically making an angle of theta here with this curve. So this basically at point M is a slope for this curve. Gradient is basically calculated using calculus. So a gradient is basically represented as dy by dx, and it's also represented in form of tan theta, theta being the angle made by this tangent with the curve at this point M. This is the theta angle here. This basically is a gradient. So difference, so both slope and gradient represents the rate of change. Okay, rate of change on both the vertical and the horizontal side, but the difference in both being slope is about the average change on a straight path, whereas gradient is about change on the curve path. Now in the next point, let's try to understand the common values of angles. Now we know that cosine basically represents the horizontal component, whereas the sine represents the vertical component. Cos is about the horizontal component, whereas sine is about the vertical component. Now let's say we draw an angle here. This is y-axis, this is x-axis, and this is center 0. Now 0 degree is an angle which is completely inclined with the x-axis. Okay, it's completely horizontal. 0 degree is completely horizontal. When we draw a 90 degree angle, which it is completely vertical, this will be 90 degree angle. Okay, when we draw an angle of 45 degree, let's say this is 45 degree, it is balanced between horizontal and vertical. 30 degree angle is more horizontal, less vertical. This will be 30 degree. Similarly, when we draw an angle of 60 degree, let's say I'm drawing an angle of 60 degree, it is more vertical and less horizontal. 30 degree was more horizontal and less vertical, whereas 60 degree is more vertical. It's more towards vertical, which is y-axis, and it is far away from the horizontal x-axis. Okay, so as we can see, as the value of angle is increasing from 0 degree towards 90 degree, okay, this was 0 degree angle, and here we draw an angle of 90 degree. So as the value is increasing from 0 to 90 degree, okay, the value of cosine is decreasing. Why? Because cosine is about the horizontal component. As the value of angle is increasing from 0 to 90, we are moving from horizontal to vertical. Okay, that means the as angle's value will increase, the cosine value will decrease. Similarly, when the value of angle will increase, because sine is more concerned with the vertical component, sine will increase. Why? Because as we move from 0 to 90, we are moving from horizontal to vertical. Okay, and 45 degree is balanced between the two. It's neither on horizontal, tilted towards horizontal, nor it is tilted towards vertical. So that's the reason why at 45 degrees sine and cosine values are equal, and at 0 degree sine becomes 0. Why? Because sine has got everything to do with vertical aspect. At 0 degree there is nothing vertical. Even at 1 degree or 2 degree there is some vertical aspect to the value of sine, but at 0 it is completely nothing for sine. So that's why at 0 degree sine is 0. And similarly, cos deals with horizontal, so at 90 degree cos will become 0. At 90 degree the value of cos will be 0. Similarly, sine 90 will be 1, because sine will be maximum when it is at 90 degree, which is the maximum vertical component. Similarly, cos 0 degree will be 1. Why? Because again 0 degree is completely horizontal, there is no component of vertical in that. So that's some basic understanding of how the values of sine and cos are. Till now, we have understood the fundamentals of trigonometry. But a bigger question here is, where do these fundamental concepts of trigonometry actually gets applied in machine learning? Let's take a couple of examples of use cases where the concepts of trigonometry actually help us in machine learning. Let's start with time calculation. Now we know that time is basically cyclic in nature. Okay, midnight basically starts at 0, and we have 24 hours in a day, 0 to 24. But the moment it starts from 0, it comes to 6, clock comes to 6, then again it reaches here to 23, which is 11 p.m. and by midnight the clock resets to 0. The moment it goes 24:00, the clock resets to 00. Okay, so that's how time basically works. It's cyclic. We can represent it like a clock is basically circular in nature. We have 3, we have 9, we have here 0, or usually 12, 6. So that's how a clock is, because it's cyclic in nature. Time is cyclic. Now let's say, for example, we have two time here. When we say time of 0, okay, 0th hour, and when we say when the hour is 23. So if we have to if the question to a machine is asked, like, are these time close to each other, or are both of these times far away from each other? So looking into the numbers, like in our previous sessions, we have understood that an ML model basically cares about numbers. So just if the model looks at numbers, so there is a huge difference between 0 and 23. Okay, since time goes from 0 to 24, 0 to 23 is a huge difference. So a model will predict that only if a number is used for this differentiation, that 0th hour and 20th hour, 23rd hour, both these hours are far away from each other, but we know in reality this is exactly not the case. 11 p.m. and midnight, 11 p.m. and midnight are very close to each other. At 11 p.m., which is denoted by 23 hours, we know after 60 minutes we reach midnight. So these are very close to each other, but number wise these are very different to each other, very far away from each other. So what do? We basically use sine and cos for this calculation. Okay, let me clean this up quickly. Okay, so the function which is used here, sine, is basically calculated as 2 pi upon 24 multiplied by the hour, for which we want to calculate time using trigonometric functions, and similarly for cos we use 2 pi upon 24 multiplied by hour. So let's take an example of 23rd hour. Okay, so 2 pi upon 24 into 23. So once we calculate it, it comes as 23 pi by 12, and mentally we can say it's 2 pi minus pi by 12. It's for our identification. Why? Because 2 pi represents complete circle. That's why we have broken down this calculation into 2 pi minus pi by 12. Now when we use this identity, sine 2 pi minus x is sine of minus of sine x. Now this is there are multiple identities of sine, cos and tan. So let's not go into details. We use this identity that sine of 2 pi minus x is minus of sine x. So x here is 2 pi minus pi by 2. So it finally comes as minus of sine pi by 2, which we know pi by 12, sorry, which we know by calculation is 0.0259. So sine of 2 pi upon 24 into 23rd hour is approximately minus of 0.259. Similarly, we calculate cos value for 23rd hour. So it breaks down to cos of 2 pi minus pi by 12. We use the identity cos of 2 pi minus x is cos of x. So this breaks down into cos of pi by 12. And let's understand the basic of this identity. We have seen that when this circle is divided into 4 quadrants, 2 pi is basically closer to full circle to this point, and 2 pi minus x is anywhere near this 4th quadrant. In 4th quadrant, sine is negative and cos is positive. So that's why sine of 2 pi minus x is minus of sine x, and cos of 2 pi minus x is cos of x. Okay. Upon calculation, cos of pi by 12 comes as approximately 0.966. So this 23rd hour, in terms of trigonometric function, evaluates to minus 0.259 and 0.966. And in case of 0th hour, we know that sine of 0 is basically 0 and cos of 0 is basically 1. So number wise, 0 and 23 are far away from one another. But when you look at the trigonometric values, 0.259, 0.966 and 1, these are closer to each other. Although the value here is 1, but 0.966 is very close to the value of 1. Similarly, minus of 0.259 is not far away from 0. So using that's the reason why trigonometric functions are basically used to calculate time in ML models. Now let's try to calculate another time for sixth hour. Okay, sine of 2 pi upon 24 into 6, it basically comes down to sine of pi by 2, similarly cos of pi by 2. So sine 90, we know that it is 1 and cos 90 is 0. So 23rd hour is minus 0.259 and for cos it is 0.966. But for 6th hour, this is for 23rd hour, this is for 6th hour. We can see there is a huge difference. Minus 2.59 is far away from 1 and 0.966 also is far away from 0. Okay, so using this we can say that 23rd hour and 6th hour, they have distance between them, they are far away from each other. But 23rd hour and 0th hour, these are close to each other, whereas these were far away from each other. But if we were to use numbers, it would be opposite. 0 and 6 have less difference, so they appear as closer to each other. But 0 to 23, they have more difference, so they appear to be far away from one another. So that's the reason why trigonometric functions have their importance to calculate time in ML models. Now let's take another use case. Another application of trigonometry in ML is in image rotation. Now an image is basically a collection of millions of pixels represented using xy coordinates. Now when we rotate an image by an angle theta, this is a rotation angle, so the position of all its pixels changes. So for every pixel, the new position is calculated using this rotation formula. For x horizontal, it's calculated using x cos theta minus y sin theta, and for vertical position, it's calculated as x of sin theta plus y of cos theta. And we know that cos is basically concerned with horizontal component and sin with vertical component. So cos here represents how much x stays horizontal after rotation, and similarly cos theta represents how much y stays vertical after rotation. Now for example, we take one point 1 comma 0, and if this is our axis, let's say this is our point P 1 comma 0. Now we make a 90-degree anti-clockwise turn. Okay, this point from here now rotates 90-degree and it comes here P dash. So we know that the value will be x will be 0 whereas y will be 1. P dash will be 0 comma 1. We know that, okay, from a basic understanding of coordinates. Now when we apply theta here 90-degree into this formula, let's see how it comes out. X dash will be x into cos 90 minus y into sin 90. Now we know that cos 90 is basically, x here was 1, let's substitute that, sorry, cos 90 is 0, y here was, sorry, x was 1, okay, y is 0 and sin 90 is 1. So 1 into 0 is 0, 0 into 1 is again 0, so it is 0. So x dash is basically 0. Okay, now for y dash, x into sin 90, x into sin 90 plus y into cos 90. So we know that x is here 1, sin of 90 is 1, y is 0 and cos of 90 is also 0. So it turns out 1 into 1, this is 1 into 1, 0 into 0, so 1 into 1 is 1. So y dash is 1. It should have been equal to. So P dash is basically calculated to be 0, 1, and on just our intuition we figured it out that by 90-degree anti-clockwise rotation p dash will be 0, 1. So even using this rotation formula involving trigonometry, we reached that same p dash of 0, 1. Now, as I said, an image has millions of pixels, so this formula gets applied to millions of pixels, and hence the final result is the rotation of image in 90-degree anti-clockwise direction. Another use case of trigonometry in machine learning is to represent sounds and signals. Now, as we speak, the sound from our mouth, it basically rises and it lowers, it rises and it lowers, and this happens in continuation. So how do we represent something mathematically that rises and that falls? So if we plot a graph here, we take x-axis and y-axis, these are coordinate. X-axis represents time, whereas y-axis represents the air pressure that comes out from a mouth. So we find the sound rises, okay, this sound rises and then it falls. This is the rise and then it falls. It again then rises, then it again falls. It again then rises, then again it falls, and it happens in continuation as time progresses. So this basically is a sine wave. This is in the wave form. Okay, so this is called a sine wave. Now, when the air pressure is maximum, that is called as peak, and when the air pressure is minimum, that is basically called as a valley in this sine wave. Now the frequency of this wave is basically is known as the pitch of sound. Okay, if frequency is less, means there are less number of oscillations, then we say that the sound is deep. The bass that we have in sound is basically the depth of the sound, or we can say the depth in the sine wave. Less number of oscillation, the frequency of wave is less. When the frequency of wave is more, so there are higher number of oscillations. That basically represents treble in sounds terminology. The amplitude here means the height of the wave. The peaks that we have, this represents the amplitude. Now, the way to represent sound using trigonometry is y equals to sine of t. T is time. Now in this sine wave, sine starts at the bottom. The value of sine, it starts at the bottom, and the value of cos starts here at the peak. So sine starts at valley, whereas cos starts at the peaks. That's how sound is represented. Now why is that the case? We know that cos of 0 is 1 and cos of 90 is 0. Similarly, sine of 0 is 0, whereas sine of 90 is 1. So when time is 0, when I say t is 0, cos will be 1, whereas sine, it will be 0. That's why sine is here in this wave at t0. This is where cos is and this is where sine is. Now as a voice is basically a continuous wave, sine wave, so we can represent sound as a1 sin f1t, a2 cos f2t. So that's basically a mathematical representation of sound. I know it's a pretty complex topic, it has its own depth, but for now we can just understand for our simplistic use case that that's how sine and cos, or basically trigonometric functions, are basically used to represent sound. Sound is basically a sine wave, and it's used, sine and cos are basically used to represent a continuous sound wave in this form. This now brings us to the end of this session. Now, this session was about revisiting the basics of trigonometry. It was not about memorizing the identities. It was not about memorizing the uh, mathematical derivations or theorems or theories. This session was about understanding how the basic or the fundamental concepts of trigonometry actually helps us in machine learning. Trigonometry is not about just triangles. It's not about the trigonometrical functions. What's the value of sine, cos, or tan? Trigonometry is about direction. It's about projection, the change that happens when we move from A to B. And machine learning is nothing but learning how to move in the right direction. If you found this session informative, please click on the like button and subscribe to our channel for future such videos. See you in the next video, guys. Till then, tata, bye bye.